Hello, welcome to Weatherwise. I am meteorologist Nathan Scott. Today we are going to get deep into the waters of the Pacific Ocean. We're going to be talking about why the sea surface temperatures and when they're warm and cold make a huge difference across the globe, including us here in Arkansas. It all amounts to, I'm sure you've heard it, La Niña, El Niño, and neutral years. We're going to really go into detail on exactly how this is all figured out in the first place and how we can forecast it going into the next several months. Let's take a look at the current conditions, though. This is the sea surface temperatures across the globe, and what I want you to notice is where the blues are and where the reds are. Where you see the blue, that is sea surface temperatures that are below average for this time of year, which was taken on November 2nd. And where you see the reds, that's where sea surface temperatures are well above average for this time of year. We're looking at specifically that little, almost looks like waves of blue going right along the equator, stretching from the central Pacific over to the eastern Pacific, just off the coast of South America. That is very important when it comes to figuring out, are we going into a La Niña situation this year, El Niño situation, or a neutral year? I'll tell you right now, the Climate Prediction Center, which is a division of NOAA, has already said we are under a La Niña advisory. So looking at that, we do have ocean waters that are below average for this time of year. But just because you see them right now doesn't mean we're necessarily going to be in La Niña. There are certain conditions that must fall into place for this to happen. I'm going to switch over here and we're going to talk about the circulations across the globe. Because before we get into what develops El Niño and La Niña, we have to talk about the basics. There are three main circulations across the globe, and this is taken from the National Oceanic Atmospheric Administration website. We've got cold air that's trying to push its way in from the poles. We've got the warm air that's rising up to the north from the equator. And you see here with all these different lines across the region, I'm going to use my cursor. This shows how the air is flowing. So in this part of the world, which is pretty high latitude, you can see the arrows are going from the surface and then up. So that tells us we have rising air in this part of the world versus the mid-latitude right here between 1 and 2, you have air that is sinking. So we have high pressure at the surface with this convergence happening that is sinking air. So that develops a surface high, and then pretty much the same story happens across the southern hemisphere. Number one, that's known as the Hadley cell. There you see at low latitudes, air moves towards the equator where it's heated, rises vertically. In the upper atmosphere, air moves poleward. This forms a convection cell that covers tropical and subtropical climates. This cell is named for the English physicist and meteorologist George Hadley, who proposed a single circulation for each hemisphere in 1735. And then number two, that's known as the Ferrel cell. This mid-latitude atmospheric circulation cell, air near the surface flows poleward and eastward, while air in the higher in the atmosphere moves equatorward and westward. And that's why we have what you call the trade winds happening once you get closer to the equator. So north of the equator, those trade winds are coming in pretty much from the northeast and headed to the southwest. And then south of the equator, the trade winds come from more of a south-southeast direction, then head off to the northwest. Why is that important? Well, let's go back over to Max 1 now, Perry, if we could, because we're going to give you a simple explanation before we get really in the weeds here with what exactly El Niño is. This is what we always show you on air, just a very simple explanation. With this, we've got ocean water that's being pushed away from South America. And as this happens, you have some cooling effect because the warm water gets pushed more towards Tahiti, more towards Australia. So therefore the waters, it's known as upwelling, come from the deeper part of the ocean and will replace that warmer water as it gets pushed off to the west. It's in balance. But some years we see things change. The trade winds will weaken, and that allows the warm water to make its way back to the east, and we'll see a buildup of warmer water in this part of the globe, and that allows for abnormally warm waters to develop in this part of the globe right off the coast of Peru. Now, they notice this because their fishing industry will really do poorly. Usually, the cold ocean waters provide a lot of nutrients for the fish and other specimens across the region. But when you have El Nino in place, that's not good news for the fishermen off the coast of Peru. So there you see the warm water building its way from the west to the east. And those warm ocean average temperatures, that really impacts what happens not only in that part of the world, but even here in the United States. Usually when we have El Nino in place, what happens is the southern jet stream is aimed at California. This is known as the moisture jet for the most part. So this is bringing a lot of moisture off the Pacific Ocean, and that's aimed at California, but also the southern parts of the United States. And the polar jet stream, that usually retreats well to the north. So when we look at the climate across the country, usually you have a warmer than average winter for the Dakotas into the northern Rockies and even the Great Lakes. Drier than average winter for the Ohio Valley, and pretty much your above average precipitation can be expected for California, into the Southwest, Texas, and also into the deep South. Now, switching gears, what happens when we take a look at La Nina? So it's almost like a little bit of a reverse effect, but not exactly. So here's El Nino in place. Now the trade winds come back, and they're stronger than they usually are. That's going to continue to push the warm water over towards Australia. It'll be replaced by the upwelling, that colder waters deeper into the Pacific Ocean, but now we're seeing an enhancement, and temperatures will be well below average for this time of year in this part of the world as that upwelling continues to be a process. So therefore, this is also going to have major impacts on exactly how the jet stream set up across North America. So when you have a La Nina in place, your moisture jet is usually much more to the north, and you'll see storms really impact Washington and Oregon with a lot of rainfall. Also over the plains, the Dakotas, the Ohio Valley, and that does meet up with the polar jet stream, and we also talk about the polar vortex. When we look at the climate usually happening with La Nina. Now, this doesn't always happen every single La Nina episode. Also, the same thing goes for El Nino, just because there's different strengths in La Nina and El Nino. We'll get into a little bit later down the road. But there you see more of a snowy winter is expected when we have La Nina conditions in place for the northern Rockies, the upper plains. Wet conditions, which could be snow, or it could be rain for the Ohio Valley. And then with that moisture jet farther to the north, you're going to see drier conditions, even the potential of drought developing across New Mexico, Texas, and also the deep south. Wet conditions, like I said, for California, Northern California, Oregon, and also Washington. Here's the breakdown now on how many events we've seen since data was taken. Now, this is all done by satellite for the most part, but since 1950, we've had 25 years of La Nina episodes. 23 of those years were neutral episodes. That means everything was in balance and there was no abnormally warm or cold conditions in that part of the world. And we've had 27 years where El Nino has taken place across the globe. 75 years, once again, since 1950, and this is known as the El Nino Southern Oscillation. That's a technical term, but coming up, we'll discuss exactly what that term means and how we use data, satellite data, to determine on if this is a La Nina year, El Nino, or neutral year. Coming up. When we take a look at if it's going to be an El Nino year, La Nina year, or neutral year, we look at what's known as the El Nino Southern Oscillation. And we're just going to take this full because there's a lot of information, but here is the terminology. The Southern Oscillation Index normally is lower pressure over Darwin, Australia. This is atmospheric pressure, and high pressure over Tahiti produces a flow of air from east to west, which pushes warm surface water west and brings precip to Australia and the Western Pacific. That is what usually happens when you have a neutral year. We have that balance across the globe with those atmospheric pressures because air flows from a high to a low pressure region. When El Nino is occurring, the pressure difference weakens and Australia experiences a severe drought. Meanwhile, heavy precip brings floods to South America. The trade winds and the pressure relationship, the warming of the tropical Pacific will decrease the pressure above by transferring more heat and making it more buoyant. Sounds complicated, so let's go over to Storm Track 11 because now we're going to look at this in almost like a 3D form of what's happening across the globe. When you have different pressures, you have rising air. So with the El Nino situation, you see what's happening here as that warm water is in place across the eastern Pacific. You have rising air, you have thunderstorm development, you have rain, and all this happening. So that creates an area of low pressure at the surface, but then that air has to go back around. So what comes up must go down, and that's what happens on the either side of this area of low pressure. So you have the air going up in this part of the world and then going down once you get over South America, and then also once you get over into Indonesia. And this also impacts Africa as well. So this is known as the Walker circulation pattern. Now with La Nina, look what happens. It's different. You have the sinking air over the eastern Pacific, and you have the rising air happening over Australia. And what did I say? El Nino brings droughts to Australia, but it brings floods to South America. And you can see the reason behind that because once again, there you go with that circulation of El Nino, that warm water all the way starting to reach its way towards Australia, that sinking air. I think it's primarily more towards China and also Thailand versus Australia according to this graphic, but you get the idea of what's happening. That pressure difference usually makes huge impacts not only for North America, but really across the globe. An index that we use for figuring out this ENSO relationship, we can go back over to Max 1 now, is because we use the relationship between the pressure gradient, which affects sea surface temperatures, and vice versa, the sea surface temperatures affect the pressure gradient in different parts of the world. We can use what's known as the Oceanic Nino Index. And this is just one way to figure out what type of ENSO phase we are in during the winter season. So primary indicator of climate pattern is the Oceanic Nino Index, or we just say ONI for short, tracks the running 3-month average sea surface temperatures in east central tropical Pacific Ocean from the international date line to near Peru. We'll go back over to Storm Track 11 now. They break these areas that they're looking at, the 3-month average sea surface temperatures, into really almost 5 regions. So there's the regions. When you look at your latitude and longitude, it starts at 160 degrees east longitude and then goes all the way really to almost 90, 80 degrees west longitude. And what we really focus on is primarily the Niño 3.4 region. That's what a lot of research is done in that part of the world. Not to discount the other areas, but it's really the Niño 3.4 that we are most concerned about. So we can go back over to Max now, Perry. I know I'm making you work today, sorry. So we have El Niño is declared when the Niño 3.4 region is seeing plus 5.5 degrees or higher above average, which is 0.5 degrees Celsius or 0.9 degrees Fahrenheit above average in that part of the world. Vice versa, La Niña is present when, in that same region, it's 0.5, I should say 0.5, not minus 5, negative 0.5 degrees lower, and that's 0.5 degrees Celsius and once again 0.9 degrees Fahrenheit, but it's lower, below average for that type of scenario. We can actually show this using a graph now since 1950, which is pretty cool to see here. And we can go back over to Storm Track 11, Perry. Hey, getting the hang of it. Thank you. So this is taken from NOAA, and it's a lot of beautiful colors, but what I want to point out is you can see how this is working out to be when you have these peaks. That's when El Niño is happening, when you have the peaks of red, and then the peaks of blue, that's when you have La Niña. So you see this red line, that's when they declare it to be a El Niño situation. The blue line, that's when they declare it to be a La Niña situation. So the last really strong El Niño situation, you might remember, was 1997. I mean, you look at this, and they take into account, you had that 3-month period. I'm going to show you the chart here, broken down just 1 second. But that 3-month period shows it's 2 degrees above average. And to take this even farther, for it to be a La Niña or El Niño, it has to be a consecutive 5-month period within that 3-month period. And we'll read that just 1 second here. So there is the El Niño, very strong, 1997, 1998. We also had a strong El Niño 2016, 2015, and then our last El Niño happened 2023 and 2024. So we got out of an El Niño. We tried to get into a La Niña last winter. It didn't happen though. It was not officially a La Niña. It was officially a neutral year across the ocean basin. And there you see our strongest, most recent La Niña, that was 2010 and 2011. And if you remember 2011, that was the big tornado outbreak that impacted the Deep South and also the Tennessee Valley. And usually when you have a La Niña in place, your chance of severe weather goes up across the United States. We'll get more into that coming up in future episodes, but right now I just wanted to break down exactly what La Niña, El Niño, and what a neutral year is. This is the chart that they use to make all those spikes. So lots of pretty colors, but once again, what you're looking at is the blue. That's when that period of 3 months, the average, shows it was La Niña conditions. But I want you to see this. Here is the reasoning behind how they figure out, okay, this is a La Niña or this is El Niño. For historical purposes, periods of below and above average sea surface temperatures are colored in blue and red when the threshold is met for a minimum of 5 consecutive overlapping seasons. The Oceanic Niño Index is one measure of the El Niño Southern Oscillation, and other indices can confirm weather features consistent with a coupled ocean atmosphere phenomenon accompanying these periods. Let's go to what happened last year. There you see it was trying to definitely go towards a La Niña with a minus 0.5 here, and then we had minus 0.6 for the period of December, January, February. But once we got into January, February, March, we started to go in more of a neutral direction, and we stayed in that direction. So therefore, last year was not a La Nina year. And sometimes we have back-to-back La Ninas. I mean, you see this long period here, 2020, 2023, we had 3 back-to-back La Ninas. But you look at the numbers, the higher the number, the stronger the episode is, and therefore the more impacts that ENSO phase would have across the globe. When you have more close neutral, it's going to be more of a balanced year. But when you have especially really strong, you see here 2.2 back in 2015 for the period of August, September, October. Now the effects for La Nina and El Nino and all this don't really kick into gear until we get into the Christmas season, the winter season. That is when the effects are really the most predominant across that region. So that's just something that you want to keep in mind. Let's see here. So we covered all that for the most part. And this website has a lot of great information. I mean, there's the different regions of the Nino indexes covered. This is all, again, easily found on the National Oceanic Atmospheric Administration, especially the Climate Prediction Center. When you have a weak episode, whether it's El Nino or La Nina, other oscillations can influence the winter season. So you may have heard the Madden-Julian oscillation or the MJO. I'm going to talk about that coming up in future episodes because, again, that has to deal with what's happening across the equatorial Pacific and really over towards the Indian Ocean, where the rising air is located versus where the sinking air is located, and atmospheric pressures, and how this wave will evolve and make its way from the Indian Ocean, and you'll have this episode of lifting air that will progress its way from India all the way across the Western Hemisphere, which can really influence hurricane season specifically, and how hurricane season can be a little bit quieter in some parts of the month versus much more active in other parts of the month, because you need rising air for those storms to develop. Well, you need rising air also for the jet stream happening and how the jet stream is oriented across the country, and the MGO can play a huge factor in that. And this is new research that's been coming out over really the past 20 years that we've realized that this has been a situation that has evolved. There's so many cycles going on across the country and across the world, and they could be anywhere between a month or 2 months to something even as long as 10 to 30 years. So another way of figuring out the ENSO is using outgoing long wave radiation, and there is the chart of that, which also shows almost like a opposite relationship, I would say, because your outgoing long wave radiation, there you go. Let's go to 1997, 2011, and 2010. That was a La Nina situation. Well, your outgoing long wave radiation is going to be a higher concentration in some aspects. And then you see the negative aspects here on the other side. So there you see OLR are indicative of enhanced or suppressed convection. So suppressed convection means less cloud cover. And then, of course, enhanced convection means more cloud cover. So that's what you're looking at right there with the blues and the reds. We'll get a little break from the deep science. We are in November now. I'm going to show you some quick facts on November here in Little Rock coming up right after the break. Before we wrap it up here on Weatherwise, it's November, so let's talk about some fun facts on November. When we take a look at the lowest November temperatures recorded at Little Rock, this is since 2013. You see, yes, we do get cold here during the month of November. The lowest temperature last year was 27, but 2019 we hit a low of 17, and the lowest temperature on record, you have to go back to 1880 where we reached 10 degrees, and then the highest low temperature on record, that was 38, set back in 1931. So our odds of seeing our first freeze here in Central Arkansas are pretty high getting into the month of November. We did have some areas of frost out there earlier this month, just this past weekend, in fact, and there were some areas of freeze, especially into Northwest and North Arkansas. But we are behind schedule because usually we've already experienced our first freeze during this part of November anyway. Now, you may wonder, with those cold temperatures, what is our chance of snow? Well, here's the breakdown of November snow reported at Little Rock now since 1875, and just want to point out the most recent was November 14th, 2018, where we had 0.2 inches of snow measured at the airport. And you may be thinking, okay, was that a snowy winter? No, that was the only snow we received during the whole winter season of 2018 into 2019. So we really got fooled thinking, oh, we had snow in November, surely we're gonna have snow in January and February. That was not the case, though. We usually don't see much snow here, though. The highest total, well, you have to go back to 1880. 9.4 inches of snow was measured back then. And then 1929, that was 4.9 inches of snow. So you get the idea that we normally don't see much snow here during the month of November, but never say never. And when I broke down the statistics for snow, this is what it came out to be. In case you're wondering, less than 1 inch of snow, that was 137 years or 95%, and then 8 years out of that total since 1880. That's all we had, 1 inch or more for 8 years or 5%. So yes, it can snow during the month of November. Usually it's not a big deal here in Central Arkansas. As always, thanks for joining me here on Weatherwise. If you have an idea, please let me know. We're going to be discussing more on La Niña and El Niño coming up in future episodes and how that impacts us with severe weather potential and also snow potential. I've got a lot more data to show you over the next several episodes. Have a great day, and I'll see you soon.